Hello, welcome to the University Challenge CT 4013 assignment project. The brief was to develop a personal project of our own choosing from start to finish. This is my video. Hello, welcome to my University Challenge. I'd like to demonstrate my Arduino powered Birdfeeder. This was designed as part of a university assignment for the CT 4013 physical computing and programming module. And basically, now the product is working, I'd like to demonstrate it and explain a bit more about it. To tell you what it's comprised of, basically it's comprised of an Arduino Mega, a Bluetooth module, and a real-time clock, which I'm still debugging, but the Bluetooth part works fine. I also got these parts here, these clear Perspex parts, cut on the university laser cutter. And to get those cut, I had to learn how to use AutoCAD. So that was something else I had to do. Apart from writing the code and designing the product, I actually had to learn how to use AutoCAD. And in addition to that, to control the Birdfeeder via Bluetooth, I actually wrote my own app as well. Don't know if you can see that. Basically, all I'm going to do is press the Bluetooth feed button, and it will dispense the right amount of food for the birds. And talking of that, I'll demonstrate that now. I've already paired the device with the phone. It's connected. So all I'm going to do is press the Bluetooth feed button. There you go. The arm moves, fills up, waits a few seconds, and dispenses the right amount of food. Now, I want to add further functionality onto this with the ability to send a tweet, no pun intended, or a text message to the bird feeder and have it feed my birds. But other than that, I'd like to take you through what I found difficult. One of the most challenging things for this project was actually the code. Initially, I started with the code before I built the product, and I spent an inordinate amount of time trying to debug it. And got nowhere quickly. So I decided to start again from scratch, and I started rewriting the code again. And it didn't take very long, I actually had the product working. And what I'll do is, with the code I actually got at the moment, I'll put at the end of the video, along with the circuit diagram, which I've done through fritzing. So you can actually have a look at the code and that kind of thing. But what I'll do is what I found easy with this was getting the concepts of sequence selection and iteration from the lectures in university and through some homework challenges that were set. This enabled me to understand these concepts very, very quickly. Although putting it all together, I found it was a bit of a challenge, but then again, I thoroughly enjoyed that. I do appreciate a challenge. The next thing for this is to get it all inside one enclosure. As you can see, it's all out of the box at the moment because it's a bit too big. But one thing you might not be able to see there, I'll show you. This is all powered just by a single battery. So yeah, it's standalone, run on itself. But you can run it via USB, and you could connect it to a computer to run it. But it needs to be portable. So battery power is preferable. One of the other things I found quite easy was actually designing the app. Because that app was designed through the MIT App Inventor. And it did take me a couple of days to get used to how it was all set up and that kind of thing. But structuring the app to actually get it functional took me a couple of attempts because I made a couple of mistakes, but I learnt by my mistakes and now it works. So I'd recommend to anybody to have a go at it because it's really, really good. And basically, yeah, I'm just looking forward to developing this product further than it is at the moment. So if you've got any questions about the bird feeder, about the circuit or the code, please feel free to get in touch. Also, I'm probably looking at a placement in the next year or so. So if you know anybody who might be interested in placing a mature student, then yes, feel free to get in touch. Enjoy.